The galaxies, the stars are generally in big clusters called galaxies. What galaxy do we live in? The Milky Way galaxy, right? Which is why if you look in the sky a certain direction, you kind of look through the side of our own galaxy, and it's kind of all white, like a milky stripe across there, because it's zillions of stars. The stars in the middle are going faster. Now, the star itself, you can't tell if it's spinning or not, but it's moving in a circle around the center of its galaxy. The stars in the middle go faster than the stars at the outside. So the galaxy is slowly winding up. The center ones are going to go faster, and it's going to spiral, it's going to twist itself in, and that's what causes the spiral arms. But this can only happen for a short time. Can't happen for billions and billions of years, because if the stars were all moving different speeds, pretty soon you wouldn't have these arms anymore. It would be just one big, smooth, homogeneous mass. You might want to get the book In the Beginning by Walt Brown. He gives the details on this and references of where you can find the proof of this. Page 23 and page 30, he deals with a lot on this. That's a fascinating book. Now, Walt Brown doesn't agree with me on a couple things, on the canopy theory and stuff like that. I'll straighten him out someday. But he's just a brilliant man, and it's really an awesome book. I'd recommend that. Yes, sir.
Do you think the book In the Beginning is better than the other book, Sail on Myself?
It's a Young World by John Morris. It's different. They're both good. If you look in your seminar notebook on page, we're talking about the age of the earth. On page 12, 13, 11, 12, 13 is where I talk about the evidence from the age of the earth. Page 11 has the sources. If you want to read good books on this topic, I've got 12 of them listed here. All of these books deal with the question, how old is the universe? And if you want to go down deep, stay down long, come up dry, this is some of the stuff you want to read right here. I would say Henry Morris's book, Scientific Creationism, would be a great one I would start with. If you want a simpler one, though that's not too hard, the very last one, John Morris, A Young Earth, we sell that here through our ministry, or you can get it through ICR or Master Books. Walt Brown, In the Beginning, number 11, is a great one. If you could only pick a few, I'd pick those three. Probably next would be number 4, Paul Ackerman, It's a Young World After All. That's a really good one. Those are some that you might want to get just to gain more information so you can document what you're saying on this topic. What I do on my slides here, I put other documentation at the bottom so I can just keep on talking and speed up, and if somebody has a question, well, they can look it up for themselves, a reference at the bottom. So the galaxies also, there's another thing I don't mention here, but I do in the seminar notebook. Not only are the galaxies themselves spinning and closing in tighter, and the arms should be disappearing, but the clusters of galaxies, you got 10 galaxies all clustered together. Together is a relative term. They're a long ways apart. But they're spreading out. The galaxy clusters are expanding, which proves they haven't been moving for billions of years. I'm real cautious. Eric, in the early days when I was doing my seminar, I would quote a number. And I would say, this proves the galaxies have to be less than 1 billion years old. And some of the skeptics who don't seem to see the forest because the trees are in the way, you know, they will say, oh, it's not 1 billion, it's 1.5 billion. You can't do your math. And they would pick on the number and still miss the whole point. So I'm real cautious now to not give specific numbers when I go through these proofs of a young Earth. And nothing proves the Earth is 6,000 years old, except the Bible. That's the only way you're going to get 6,000 is from this book. Now, there's ways you can limit it to less than billions, but the only way you're going to get 6,000 is right here. Red stars, they call them a red giant star. Now, I have to stop right here and say, you get the biggest telescope in the world, you look at the closest star, you cannot tell how big it is. All you see is a dot. So I think it's probably true that red stars are larger, but we don't know that for positively. All the astronomers say the red stars are larger. How do you know that? Well, we think it's larger. Well, okay, maybe it is, and it probably is, but I'd be careful about being dogmatic about that. You cannot see the size of any of these stars. You can't even see a star. You don't see the surface, I mean, like you see the sun with the flames leaping off. Get the biggest telescope in the world, look at the closest star, which is Alpha Centauri, and all you see is a dot. You get a bigger telescope, you see the dot better. That's about it. When they put the Hubble up, somebody said, are you worried when they put the Hubble up they're going to prove evolution? I said, oh no, I can tell you exactly what they're going to see with the Hubble. They said, what? I said, they're going to see more stars. That's what they did, too. It's neat to go out at night and look at part of the sky, let your eyes focus on it, and all of a sudden more stars start appearing, and then get a telescope and put it up there. And it's like, wow. Things that you thought were just a few stars, all of a sudden now that little dot is an entire galaxy of billions of stars. It's unreal. I've got a video clip I need to add in here about, all right, I'll put it in part 7 probably. Somebody did that. They took a video through a telescope as they were zooming in. And what looked like just a few stars, all of a sudden these stars became entire clusters of galaxies, and it's blow your mind. It's so beautiful, you know. I hope when we get to heaven, the Lord allows us to travel at the speed of thought. All you got to do is think about being somewhere. I'm glad students can't do it now, because they'd be in and out of the room all the time, you know. I think I'm at the beach. Hey, come on back. Of course, at the speed of thought, some people would go pretty slow, come to think of it. But you know a few of those, do you? Okay, textbooks say that red giant stars slowly evolve into a white dwarf star. Now, it seems to be true that red stars do change to white stars after a while. And they've got a whole series set up of how this happens. And if you take an astronomy course, they'll go through all the go down deep, stay down long kind of stuff on how stars burn up a certain amount of heat and they get rid of a certain amount of critical mass and then they collapse on themselves and expand. And they've got all this stuff all theorized. I wouldn't argue with them. Maybe it's all true. I don't know. I don't think they know either. However, they're going to say to go from a red star to a white star takes hundreds of billions of years, or billions of years. This textbook says, if you look in the lower left-hand corner, it may take 100 billion years, or 10 billion years, or just a few billion years. The average size star, like our sun, would be in the middle there. They're going to say it takes, in 10 billion years, it'll change to a white dwarf. And they've got it all figured out how the sun, when it burns up a certain amount of fuel, it no longer has enough gravity to hold it together. So it'll swell up like a marshmallow does when you get it hot over a fire. When it swells up, then it collapses back on itself, boom, and turns into a little tiny white dwarf star. And then that explosion, all that process is where the nova and supernova comes in. The star explodes. And they say the sun is going to swell up as big as the Earth's orbit, and we're all going to be fried in about 10 billion years. Oh, you better get a life insurance policy now, you know. Anyway, I doubt that's going to happen. But the stars do change. And yet, all of the ancient astronomers, if you go back and read the records, yes?
You don't doubt that it's going to happen. No,
it's not going to happen, period. God's heaven and earth, well, heaven and earth shall pass away, but my word shall not pass away. So maybe he will let that happen that way. Interesting verse when it says the sun is going to scorch men in the book of Revelation. They'll be scorched with a fervent heat. Some Bible scholars will say, see, that's the beginning of a supernova. The sun is swelling. Well, it could be, or it could be the atmospheric conditions are different, you know. Just changing the atmosphere would scorch everybody here. You don't have to make the sun larger. Go to Sahara Desert, you want to get scorched, you know. 130 degrees, that'll scorch you right now. This idea about red stars changing to white stars is probably true. But all of the ancient astronomers referred to Sirius, which is the brightest star in the sky. If you go out on a cloudless night, other than the planets, which appear even brighter because some of them are, you know, so much closer, the brightest star is the star Sirius. Now, it's not the closest star. It's the brightest star. Everybody referred to Sirius as a red star. You know, the ancient astronomers did. Today, it's a white dwarf star. This information comes from the book, It's a Young World After All. It's a Young World by Paul Ackerman, which we have, I believe, right, Dan? It's out of print, isn't it? But we still have some left? It's back in print? Okay. Yeah, I've talked to Paul Ackerman on the phone several times. He said there's a couple things he'll change about the book next time that he's found out are not quite accurate, but 98% of it is really great. One atheist wrote me a very nasty letter about my mention of Sirius being a white star. And he said, don't you know Sirius is a binary star? There are two of them going around. I wrote back and said, yeah, and they're both white. So what's your point? It appears to be a binary star, two stars spinning around each other, and they're both white stars. So, just so you know that in case somebody questions you on that. Yes, it's binary, but they're both white. Okay, let's move in now. Instead of from stars, though there's lots of evidence from space that the universe is not billions of years old, let's move in just to our solar system. Two different words you need to be careful, Eric, not to confuse is the universe and the solar system. Solar system is just our 9 planets and the sun. The universe would be everything, all of the stars and planets, etc. Jupiter is a huge planet, but it's cooling off. Estimates are that it's losing its heat twice as fast as it gets it from the sun. Let's see. My very extravagant mother just sent us 90 parakeets, was the way to memorize the planets in order. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. And if you want to memorize the distance to the planets, which I made my students do in Earth Science class, just to get a few of them, you can do it as an astronomical unit. It's a quick way to do it. Mercury is the closest one. It's 0.39. Venus is 0.7. Earth is 1. The distance from the Earth to the Sun, 93 million miles, is called an astronomical unit, AU. We'll get into that more of that later. Mars, I believe, is 1.5. Jupiter, which we're talking about here, if I recall, is 5 astronomical units. That means it's 5 times farther away from the sun than we are. If you're on Jupiter, the sun would look real small and would supply you with very little heat. Even Mars at 1.5 astronomical units is real chilly. 50% farther away than we are. These 4 planets are called the inner planets, and if you put it on a scale, you can do it with a ruler, you know, 0.3, 0.7, 1, 1.5, 5. The next one, I believe, is 9. It goes clear out to 39, which is Pluto. 39 astronomical units away, which is why Pluto wasn't discovered until just recently. You got to have a really good telescope. And even then, they only noticed there might be another one because one of the inner planets was moving a little bit. In its orbit, it kind of bumped out of orbit. They said, oh, something must be pulling it. And that's how they detected Pluto, because another planet wasn't quite in the exact same spot where it's supposed to be based upon normal orbit. Who cares? Okay, you can get into that in Earth Science class. Anyway, the point is, Jupiter's way out there, 5 times farther away than we are, and gets very little heat from the sun, and yet Jupiter is still hot. Now, how can you keep losing heat for billions of years? Wouldn't you pretty soon be cooled off? We cover in here evidence from space on page 11. If you want to read more references about this, you can document it. For instance, item number 9, Saturn's rings are unstable, they're breaking up. Jupiter and Saturn are cooling off rapidly. They're losing heat. You can see the reference here. Reference number 5, page 26. That would be from Edward Blick's book, Scientific Analysis of Genesis. Also reference number 4, page 43. That would be from Ackerman's book, It's a Young World After All. Anyway, the way this works in the seminar notebook is so that you can look up the reference and the page number. It's kind of written right in here. It's a little different way to footnote, I know, but it's very fast and efficient. That's the way I use. You know, it's not probably the standard way, which I very seldom have cared what the standard way is for anything. So, right, Dan? That's true. So the references here, that's how it works with your notebook. Jupiter has a little moon called Ganymede. It's not really that little. It's about the same size as the planet Mercury. So this Ganymede is one of the, I don't know how many there are now, maybe 20 moons around Jupiter. It's a lot. One of the moons, called Ganymede, is, as one of the Voyager's space probes went through it, the Jupiter probe, said there's a very strong magnetic field. And all they can figure is a magnetic field has to be produced by the inside core being hot. And to have something that small be that hot, when it's that far away from the sun, is surprising. A smaller body cools off faster than a larger body. The reason for that is, without going too far down this rabbit hole, your surface area increases in proportion to your volume as you decrease in size. Did we erase all that from the last time? No. Here. Okay, if you have a little cube that is 1 inch, 1 by 1 by 1, 1 inch cube, it has 1 cubic inch of volume. 1 cubic inch. The surface area, how many square inches of surface would it take to build that cube? 6. It has 6 square inches of surface area. Now watch this. So my ratio is 1 to 6, right? Now let's make our cube twice as big. 2 inches by 2 inches by 2 inches. What's the volume? 2 times 2 times 2 is 8. What's our surface area? 4 on each side. There are 6 sides. 24. What's our ratio? 1 to 3. You see what happened? This is a very important concept to understand because as you get smaller, if we made a cube that was 1/2 inch on each side, you would have 1/2 times 1/2, which is 1/4 of an inch on each side for the surface. 6 of those. You have 6/4 of an inch. That's 1 1/4 inches. Let's make this a 1/2. Oh, I'm sorry. This is for a 1 inch. This is for a 2 inch. Let's go to a 1/2 inch cube. I probably should put it above so it doesn't confuse people conceptually. Volume, surface area. If we go to a 1/2 inch cube, we now have a surface area of 1 1/4. And who's got a calculator? 0.5 times 0.5 times 0.5. Or 1/8, which is okay, well, to keep it as fractions, it'd be easier to work with. Okay, 1/8 to 1 1/4 is a ratio of 1 to 12. Now look what's happening here. We have very little volume and a whole lot of surface. As a creature gets smaller and smaller like an ant, pretty soon they have so much surface and so little volume, they fall out of a tree, hit the ground and walk off. Elephant falls out of the tree, bam! Right? This problem right here is one of the reasons elephants are wrinkled. Because they have so much body mass, they have to get wrinkles in the skin in order to radiate the heat away. The other reason they're wrinkled is because they're very difficult to iron. But as an animal gets larger and larger, the surface area to volume ratio becomes a serious problem. Now this will be important later, Eric, when we get into this about insects. Since insects don't breathe through their mouth like we do, they absorb oxygen through the skin. Every cell in their body needs oxygen, but as your surface area to volume ratio diminishes, you just simply can't get enough oxygen to supply it because you don't have enough skin. The only way you can get a huge insect is to increase the air pressure. There's a maximum size insects can get based upon the air pressure. So one of the proofs we'll get into later that the world before the flood was a lot different is the fossils we find of giant insects. This is a good proof that something was different. Sometime in the past, there must have been a lot more air pressure because of this surface area to volume ratio problem. Okay, enough on that rabbit trail. I've always wanted to chase it in my seminar. I never got time to. No, we did. Okay, Ganymede is a large planet. I mean, it's a large moon, but compared to Jupiter, it's real tiny. Now, because it is smaller, it has really a greater surface area to volume ratio problem than Jupiter does. So it should lose heat even faster than Jupiter. One of the reasons, if you want to cool something off, you got a hot piece of, potato, for instance, you break it up and spread it out. All you're doing is increasing the surface exposure. When you want to get something to dissolve faster in water, you break it up. Drop in a lump of chunk of ice into your glass, or take the ice cube and crush it and drop it in. Same amount of ice, the ice cube will last longer and dissolve slower than the crystals, the small pieces, because now more surface is exposed to be dissolved or whatever. It's a principle you can use all through science. Who cares? Point is, Ganymede is still hot and it shouldn't be. And they admitted in the newspaper article here about Ganymede should have cooled solid billions of years ago. Why does it still have a magnetic field? So what they've done over this Ganymede problem, when the space probe sent this data back and said, look, Ganymede has a strong magnetic field. The scientists start with the assumption, Well, we know it's billions of years old, so how did this happen? The thought never enters their mind that maybe it's not billions of years old. So they're busy looking for ways to keep their evolution, age of the Earth necessity, you know, billions of years. They have to keep that. What they've said is maybe Ganymede, maybe something passed by Jupiter, and the gravitational pull of this passing star or whatever pulled Ganymede in closer to Jupiter. And because it was closer, the gravity of Jupiter was stronger, so it's pumping it and it's squeezing the surface, and that's what increased the temperature. And then, poof, it popped back out to its orbit where it is now. They got to come up with all these wild ideas just to try to save the one concept that the universe is billions of years old. So when you read the articles on the web about me, and there's some really interesting ones, some of these scoffers, they write whole books, you know, answering Hovind's, you know, young Earth arguments. It's hilarious to read. When you stop it, they think because they talked, they answered the question. This is a rule teachers soon learn. The longer the kid's essay answer is, the less he knows about it. How many of you ever did one of those essay questions where you tried to snow the teacher? You know, you don't have a clue what's going on, so you just talk, and pretty soon they get tired of reading and think, well, he must know what he's talking about. You know, give him an A. And some of these scoffers went to school and never did learn to overcome that problem, and so they write these long diatribes about me, and they'll say, don't you know that Ganymede is still hot because it got sucked in and was pumped by Jupiter's gravity and then flung back out, you know? Well, you can believe all that if you want. The fact is, it's hot. The fact is, you've got to do all sorts of mental gymnastics to come up with an answer for this, when there is another obvious possible answer. It's not billions of years old. That's the simplest, most logical answer. It's not billions of years old. But I will tell you, to everyone I'm going to give you here, they do have what they claim is an answer to it. But you got to just read it slowly and carefully, and you realize how dumb most of them are. They just are silly. Yes, sir?
The same idea, we used to believe the Earth was the center of the universe until retrograde motion kept getting in the way.
Right.
Kept going, well, sometimes they move backwards. And
yeah, the circular planets, yeah. The orbits of the planets going epicycles, I know. People get a pet theory and they just try to hang on to it desperately. We probably all do that. Okay, everybody's blind to their own, you know, problems, but they certainly do that with evolution. They will fight desperately to keep the Earth and universe being billions of years old, because otherwise your frog can't turn into your prince, you know, and you got to have that. Saturn and four planets have rings around them. Saturn's are the most visible. We saw them the other night with a telescope. Remember that out there? And it's just like a 2-inch telescope, a spotting scope for the target range. We could see the Saturn's rings. It's really incredible. Saturn's rings are made of rock and ice. Saturn's rings are beautiful as you get up close to them, and there have been several probes have gone by and photographed them, even gone through the rings, and verified they are indeed rock and ice. Extremely cold ice. Now the reason they're in a ring on the equator, if you had a basketball covered with water and you started spinning it, what would happen to the water? It'd fly off at the equator, wouldn't it? That's the fastest moving point, right. So Saturn is spinning, and you can tell where the equator is on Saturn by where the rings are. 4 planets have these rings. Saturn's are the most visible, these ice and rock rings around them. But the rings are unstable. They're moving around. Different moons are going around Saturn, and some people call them shepherding moons. Each of these moons has a gravitational pull. So you got these moons going around these rings also, and they're pulling these crystals of ice and rock out of their orbit and then dropping them back in. As the moon passes, it loses its gravitational pull. Well, how long can that process stay going and the rings still stay intact? You can't just keep messing it up continually and have it still stay intact. It's a known fact, and there's good information about this in Walt Brown's book, In the Beginning. Got the references right there, page 29 and page 69. He goes through all the details on, you know, the Saturn's rings. The fact is, they're unstable, they're expanding. They can't be billions of years old. So, the evolutionist looks at this, they do all the studies and say, wow, the rings are moving, probably less than 10,000 years old. Then they'll come along and say, see, this proves something nearly hit Saturn 10,000 years ago, got shattered and got caught in the spin and became the rings. Maybe so. But maybe it's because it's not billions of years old. So their answer to this is a moon or something came by and shattered into fragments, and it's now the rings. And yes, it is less than 10,000 years old. But that doesn't prove Saturn is. That's what they'll say. I had another point on that I was going to make and I forgot it. Oh yeah, in my video number 6, the Hovind theory, where I cover about an ice meteor possibly being the cause of the flood here on Earth. If an ice meteor, and outer space is full of these big comets that are super cold chunks of ice and snow, if one of those came and hit the Earth, or just came near the Earth, or shattered and came through our solar system like a shotgun, fragments of broken ice crystals, that may be where the rings of Saturn came from. They may indeed have been caused, the 4 planets, plus the craters on the other planets, plus the flood here on Earth, might have all been caused in a giant solar catastrophe. I mean, solar system catastrophe. An ice meteor is, in my opinion, the most logical candidate. Now, I call it the Hovind theory because I don't know for sure. I look at all the evidence, hey, seems to fit. I tell people, if you have a key and it fits the lock, that doesn't prove that's the key for the lock, but it could be, right? And if you have a theory and it fits all the observations, well, maybe you have the right theory. Doesn't prove you do, but it's better than if your key does not fit the lock. Now you know you have the wrong theory for sure. Evolution. It doesn't fit any of the locks. Okay, let's come in a little closer now. We look at our planets in space. We can also look at the fact that so many of these planets have really good orbits, almost perfectly circular orbits, you know, egg-shaped a little bit, but amazingly good orbits. And the planets themselves are amazingly round. The moon, for instance, is just almost perfectly a round ball. It is spinning so slow, there's very little bulge at the equator. The Earth is spinning a lot faster, and there's about a 20-mile bulge. The equatorial diameter is 20 miles farther than the polar diameter. If you spin a basketball real fast, it'll flatten out like a frisbee. You'd have to get it really fast. But the Earth is spinning once a day, which flattens it out a little bit, pulls the poles in, sucks the equator out, about a 20-mile difference, which really is nothing compared to 8,000-mile Earth. You know, from space you can't see that 20-mile difference. The moon is, I don't know what it is, like 1 or 2 or 3 mile difference. It's very little. The moon is spinning once every 29 days. It also goes around the Earth once every 29 days, which is why we never see the other side. As it's turning, it's always facing us, you know. They never see the other side of the moon unless they go out there and take a picture with a rocket or something. But the moon is going around the Earth once every 29 days. The moon is almost perfectly smooth. The theories of how we got the planets and the moon all fall apart. There's the most common theory, I think probably the most common theory now, is called the accretion theory. They will say the planets formed after the Big Bang, all these particles flew out, and then they all started drawing together because of gravity, and the more mass you get, the stronger gravity becomes, and they start sucking in particles, and pretty soon, you know, you got a planet. Well, you'd have a clump of rock stuck together. What's going to cause it to melt into this perfectly smooth ball? And so their answer to that one is, well, meteors hit, this supplies heat and energy. And that's what melted it. Oh. Well, there are some marks on the moon, but the moon is in an almost perfectly circular orbit around the Earth. And it's almost perfectly round. I mean, I don't think that's going to form by an accretion of particles over billions of years. Now, if you want to believe that, that's fine, but that's not science, that's religion. That's what they believe. And that'll be their answer to this one. But the moon goes around the Earth, but the moon is gradually getting farther away. We're slowly losing the moon. It's leaving us. The numbers vary. Now, people argue about this. There's good articles about this here. The impact article from Institute for Creation Research. If you want to get some fascinating reading, these little impact articles, they're just one-page articles. They're 10 cents a piece, and they started them in 1974, I believe. And they're up to number like 350 now. So for 35 bucks, you could get all of the back issues. And it is just amazing reading. I mean, that's an entire course in itself, just reading all the impact articles that they put out for the last 25 years. This one is impact number 110, published in 1982, August of 82. And you can still, I think you can get some of these on ICR's website, icr.org. But they go through, by Thomas Barnes, was a University of Texas, El Paso. I've spoken there twice, done debates at University of Texas, El Paso. Matter of fact, recently, last month, yeah. He was a physics professor there. He was a young Earth creationist. And they didn't like him because they didn't want a University of Texas professor who believed the Bible. They tried all sorts of things to, ridicule him. He's now, if he's still alive, he's probably in his 80s. But I've talked to him a couple times on the phone. Really gracious man. He wrote this article 20 years ago about the young age for the moon and the Earth. showing that because the moon is getting farther away, that means obviously it used to be closer. Now if you bring the moon in closer, you create a problem, because the moon is what causes the tides. Now I don't worry about the tides here, even though I'm in Pensacola, because we're 60 feet above sea level. But the folks along the beach worry about the tides, right? Mom and I, a few months ago, were in Alaska, and we got to see the second highest tides, which is where Anchorage, Alaska is, which is where it got its name, Anchorage, a good place to anchor. But I forget the name of the bay now, but it goes up and down. That's the second highest tides. Generally, the world's tides, I think, probably average around 3 or 4 foot tidal change, from high tide to low tide. Pensacola here, it's not even that. It's probably only 2 feet. Very small tidal change. Other places, it's 50 feet. But the moon is causing these tides. As the Earth is turning under the moon's gravity is pulling on the water. This creates a squeezing effect. On the sides of the Earth, it squeezes in, and it pulls the water up on one side, and because of the squeezing effect, it pushes it out on the other side. So you actually end up getting a high tide on the opposite side from the moon. But the high tide on the other side is not quite as high as the high tide on the near side. If nothing was moving, just the Earth spinning, you would get a high tide every 6 hours. Or you'd get a high tide, 6 hours later you'd have a low tide, 6 hours later another high tide. It would all be real nice every 6 hours. But because while we're spinning around, the moon is also moving. And so you have 2 motions to consider. So the average is every 6 hours and 25 minutes you have a tidal change. Because in 6 hours, the moon has moved 25 minutes worth in its orbit around the Earth. Who cares, right? Okay. The point is, if the moon were closer, the tides would be higher. And we'll finish this one thought here and close on this. There's a law in physics called the inverse square law. And I want to put this on the quiz. What is the inverse square law? Be able to explain this. If 2 objects are attracted to each other, how strongly do they pull each other? 2 magnets, let's say. If you get the magnets half the distance apart, you take the fraction 1/2, inverse it, and square it. It's now 4 times the pull. If you brought the moon back into 1/3 the distance, you take that fraction, 1/3, inverse it, that means flip it over, and square it. It's 9 times the pull. When you're measuring how bright a light is, my dad was an electrical engineer at Caterpillar Tractor Company. He was showing me all these charts and graphs they use. You got a bunch of people in the office, how much light do you want at the desk for the guy to work? Then you got to figure out how far away is your light on your ceiling, how many candle power does it produce, because if you double the distance, say I'm 5 feet away from that light, and it looks to be as bright as 100 candles. If I went 10 feet away, it'd only be as bright as 25 candles. Inverse, I think that's the right number, is that right? Inverse square? I have to do my math on that, but it would drop off as logarithmically as opposed to linearly. As you get closer to the light, you half the distance, it's 4 times as bright. You half it again, it's 16 times as bright. The inverse square laws, I will cover that in video number 6. They apply when you're dealing with forces involving magnets, gravity, light, and girls. When you half the distance, the attraction is quadrupled. A lot of guys don't understand that till it's too late, and we'll get into more of that later. But this inverse square law says if the moon were closer, the tides would be higher, much higher. The problem becomes worse the farther back in time you go. So the evolutionists have tried to answer this by saying, well, you don't know that the moon has always been moving away at the same rate. Good point, I don't. We do know it was closer. And if it's getting farther away, it used to be closer as you go back in time. This does put some kind of time limit. We cover in here evidence from space about the moon. This is which number? Yeah, number 5, page 11. You can get more information on this from source number 3, Scott Hughes, The Collapse of Evolution. Number 6 is Dennis Peterson, Unlocking the Mystery of Creation. And number 11, Walter Brown's book, In the Beginning, about the moon. Okay, back up one slide. So I'll ask you to explain what is the inverse square law. That's the law that says as an object gets closer, the gravity increases, the pull, the force of the increases as the inverse of the square of the fraction. That's not a good way to phrase it. Let's just say it like this. If you half the distance, it'll quadruple the traction. If you bring it into 1/3 the distance, it'll be 9 times the pull. And what phenomena does the moon cause on the Earth? The tides. Put that down. Heidi, is a quiz question. Also, actually, the moon causes what's called a land tide. As we turn under the moon, Pensacola lifts up about 2 inches. The entire city. We don't notice it because all of Florida is going up 2 inches. You know, goes up, goes back down. Called a land tide. Now, if you get a land tide going up and down, this can create stresses on the crust of the earth a little bit and can trigger earthquakes or can increase the likelihood of them happening. Pardon me? How could you tell the earth is going up?
Yeah, how can you tell?
I don't know how they tell that. I'm sure there's ways. Get up there in a helicopter and that wouldn't work because then the air is going up too. Maybe it's just been calculated as opposed to just by the mass of the, done theoretically. I don't know that it's actually been measured. Some things are theoretical and, are logically true but cannot be proven. So that's a good question. Theoretical science instead of empirical science. Okay, so if we ask you on the quiz to name some ways to show the earth is young, what could you name so far? Quick review. Population. I should say, phrase the question, Heidi. Name some ways to show the universe is young, not the earth. Population shows the earth is young. That'd be one, would count. Galaxies are spinning. That's another one. And the distance to the moon is increasing. Jupiter is cooling off. Ganymede is way too hot. And Saturn still has rings. Those are 6 we've covered, right? What's that? Tanya, are you griping or complaining?
No, I said yes.
Yes. Okay, thank you, Tanya. If you're going to be a Hovind, you have to learn to take ridicule. We get it all the time, right? We gave 6. I'll probably say name 4 ways to show the universe is young. We're going to get into a lot more. Okay? Put that as a question. They're all in the notebook, yeah.
I got them all done here, but I just want to make sure.
Yeah. For the quiz, we'll say name 4 ways to prove the universe. I wouldn't say prove. 4 factors that indicate the universe is young. Kind of steer away from the word proof. It's not a good word to use. Okay. Any questions? What we covered so far? Great. Dismissed. See you next week.